A pleasant day to all of our viewers. I am Mr. Timothy Acana, and I am your online grade 8 mathematics teacher for today. At the end of the lesson, you should be able to learn the following skills. First is to define and illustrate defined and undefined terms in geometry and to give real-world representations of defined and undefined terms in geometry. Before we start our lesson for today, let us recall your previous topic in grade 7 mathematics. Let us answer the activity entitled, What Am I? The directions for the activity are simple. All you need to do is determine whether each of the following represents a point, a line, or a plane. You can type your answer in the comment section. Are you ready? Let us start. First, let us have stars in the sky at night. Does this represent a point, a line, or a plane? And the correct answer is, it represents a point. Were you able to comment the correct answer? That is great. How about a piece of rope? Does a piece of rope represent a point, a line, or a plane? And the correct answer is, it represents a line. Wonderful. Next is the top of a table. Does this represent a point, a line, or a plane? And the correct answer is, it represents a plane. You are doing great. How about the edge of a book? Does this represent a point, a line, or a plane? And the correct answer is, it represents a line. Amazing! And lastly, we have grains of sand. Does this represent a point, a line, or a plane? And the correct answer is, it represents a point. Were you able to get all the correct answers? That is great. Before we proceed to our topic, let us first define what a mathematical system is. Mathematical system is a structure formed from one or more sets of undefined objects, various concepts which may or may not be defined, and set of axioms relating these objects and concepts. Here is a concept map of a mathematical system and its parts, namely the undefined terms, defined terms, postulates, and theorems. Today we will be discussing two of them, the undefined and the defined terms. Undefined terms do not have any actual definition. It may be represented by different figures from the real world, while defined terms have a formal definition and can be defined using other geometric terms. Then we have the postulates and theorems. Postulates are statements that assume to be true, while theorems are statements that can be proved to be true. Unlike in the real world, points, lines, and planes do not have any actual definition. In all branches of mathematics, some fundamental pieces cannot be defined because they are used to define other more complex pieces. In geometry, three undefined terms are the underpinnings of Euclidean geometry: the point, the line, and the plane. First, let us discuss what is a point. A point refers to a specific location. A dot is used to represent a point. It has no length, width, and thickness and can be named using a capital letter. Example, we have here point B. Here are some other representations of a point. We have a tip of a pen and grains of rice, both represents a point. Next is a line. A line is made up of infinitely many points. Two distinct points determine a line. It has no width and thickness, but it has an infinite length that can extend indefinitely in two opposite directions. It can be named using two capital letters or any 2 points on the line, or using a small script letter. Example, line AB or line M. Here are some other representations of a line. We have horizon between the sky and the sea, and shoelaces both represents a line. Lastly is a plane. A plane is a flat surface made up of infinitely many points that extends in all directions. There is exactly one plane in any 3 points not on the same line. It has no thickness, but it has an infinite length and width. It can be named using a capital script letter placed at one of its corners or by at least 3 non-collinear points on the plane. Example, plane JEH or plane R. Here are some other representations of a plane. We have top of a notebook and a piece of cloth, both represents plane. On the other hand, we have what we call defined terms in geometry. Defined terms refer to the terms that have a formal definition and can be defined using other geometric terms. Here are some examples of defined terms in geometry. First, let us have the definition of collinear points. When 2 or more points are lying on the same line, then they are called collinear points. Example, let us refer to the given figure. Points A, B, C are collinear, while points B, C, and D are non-collinear. Next, we have the definition of coplanar points. When 2 or more points are lying on the same line, then they are called coplanar points. Example, we have points A, I, and R are coplanar, while points A, I, and P are non-coplanar. Then we have the definition of coplanar lines. When 2 or more lines are lying on the same line, or the same plane rather, then they are called coplanar lines. Example, we have here on the figure, line L and line N are coplanar lines, while line L and line M are non-coplanar lines. Next is the definition of line segment. Line segment AB, or line segment AB written in symbols, is the set of points which includes A and B and all the points between them, where A and B are the endpoints of the segment. Let us refer to the given figure. We have point X, Y, and Z, which are collinear points. In the given illustration, how many segments can be named? Very good. The correct answer is 3. Can you name them all? That is right. The segments are segment XY, segment XZ, and segment YZ. Next is the definition of ray. A ray is a portion of a line having one endpoint and goes indefinitely in one direction. Ray AB, or ray AB written in symbols, contains the endpoint A and all other points on the line from A to the direction of B. To name a ray, you start from the endpoint. Now let us refer to the given figure. We have again points X, Y, and Z, which are collinear points. In the given illustration, how many rays can be named? Very good. The correct answer is 4. Can you name them all? That is right. The rays are ray XZ, ray YZ, ray ZX, and ray YX. Next is definition of betweenness. Point N is said to be between points A and T if and only if A, N, and T are distinct points on the same line and AN plus NT is equal to AT. Let us refer to the given figure. We have distinct points C, A, and T, which are collinear points, and point A is between segment CT. If A is a point on segment CT, and CA is equal to 3, and AT is equal to 5, then what is the measure of the whole segment CT? Very good. Segment CT is equal to 8. Next, we have the definition of midpoint. If points A, N, and T are collinear points, and N is the midpoint of segment AT, then segment AN is congruent to segment NT. Again, let us refer to the given figure. We have distinct points S, U, and N, which are collinear points. And point U is the midpoint of segment SN. If U is the midpoint of segment SN, and SN is equal to 12, then what is the measure of segment SU? Very good. Segment SU is equal to 6. Next, we have definition of an angle. An angle is the union of two non-collinear rays with a common endpoint, called the vertex, and two rays is called the sides. In angle ABC or angle ABC written in symbols, B is the vertex, and ray BA and ray BC are the sides. Next is the definition of angle bisector. If point S lies in the interior of angle PQR and ray QS bisects angle PQR, then angle PQS is congruent to angle SQR as shown in the figure. Example, if angle PQR is equal to 60 degrees, then what is the measure of angle PQS? Very good. The answer is angle PQS is equal to 30 degrees. Another example, if angle SQR is equal to 24 degrees, then what is the measure of angle PQR? Wonderful. The answer is angle PQR is equal to 48 degrees. Next is the definition of adjacent angles. Two angles which have a common vertex and a common side, but have no interior points in common, as shown in the figure. The two adjacent angles are angle ABX and angle XBC. In the given figure, can you identify the common side? Very good. The common side is ray BX. How about the common vertex? Can you identify it? That is great. The common vertex is B. Next is the definition of supplementary angles. Two angles are supplementary if the sum of their measures is 180 degrees. In the figure, measure of angle M plus measure of angle N is equal to 180 degrees since the measure of angle M is 70 degrees and the measure of angle N is 110 degrees. And its sum is equal to 180 degrees. Therefore, angle M and angle N are supplementary angles. Another example, in the given figure, suppose that angle M is equal to 62 degrees. What is the measure of angle N? You are right. The measure of angle N is equal to 118 degrees. Next is the definition of complementary angles. Two angles are complementary if the sum of their measures is 90 degrees. In the figure, since angle STU is a right angle, and point P lies in the interior of angle STU, therefore, measure of angle STP plus measure of angle PTU is equal to 90 degrees. And angle STP and angle PTU are complementary angles. In the given figure, given that angle STU is a right angle and angle PTU is equal to 35 degrees, what is the measure of angle STP? Very good. The answer is angle STP is equal to 55 degrees. Next is the definition of linear pairs. Two angles form a linear pair if and only if they are adjacent angles, whose non-common sides are opposite rays. Thus, linear pairs are supplementary angles. In the figure, angle MAT and angle EAH form a linear pair, and measure of angle MAT plus measure of angle EAH is equal to 180 degrees. In the given figure, if measure of angle MAT is equal to 104 degrees, what is the measure of angle TAH? That is right. Angle TAH is equal to 76 degrees. Next is the definition of vertical angles. Two angles are vertical angles if and only if they are non-adjacent angles formed by two intersecting lines. Vertical angles are congruent. In the figure, angle A and angle C, angle B and angle D are vertical angles. Thus, angle A is congruent to angle C and angle B is congruent to angle B. In this given figure, suppose that measure of angle A is equal to 43 degrees. What is the measure of angle C? You are correct. Angle C is equal to 43 degrees since they are vertical angles and they are congruent and equal. To determine if you were able to understand our topic for today, let us answer the given activity entitled, "What do I represent?" The directions for the activity is simply to name the undefined term in geometry which is modeled by each object. If the undefined term being represented is a point, press the like react button. If it is a line, press the heart react button. And if it is a plane, press the haha react button. Are you ready? Let us start. What does a blanket represent? A blanket represents a plane. Were you able to press the react button? That is great. How about the edge of two connected walls? What does it represent? The edge of two connected walls represents a line. Did you press the heart react button? Amazing. How about tip of a pencil? What does it represent? Tip of a pencil represents a point. Wonderful. How about a star from afar? What does it represent? A star from afar represents a point. That is great. How about an electric wire? What does it represent? Were you able to press the heart react button? Amazing, because an electric wire represents a line. How about the edge of a desk? What does it represent? Very good. The edge of a desk represents a line. Were you able to press the heart react button? How about the surface of a floor? What does it represent? Very good. The surface of a floor represents a plane. How about a knot in a rope? What does it represent? Amazing. A knot in a rope represents a point. How about a beam from a laser? What does it represent? A beam from a laser represents a line. Wonderful. And lastly, what about a curtain rod? What does it represent? Very good. A curtain rod represents a line. Did you enjoy the activity? That is great. Now let us have another activity. Let us try to answer the following using the given figure at the right. Determine whether each statement is true or false based on the given figure. If the statement is true, press the like react button. And if it is false, press the heart react button. Are you ready? Let us start. Based on the figure, do lines M and N intersect at point A? Very good. The answer is true. Were you able to press the like react button? Great. How about points A, B, and E? Are they collinear? Wonderful. The answer is false, since they do not lie on the same line. Next, we have planes P and Q intersect in line M. Is it true or is it false? Very good. The answer is true. You are doing great. How about points B, C, and F? Are they coplanar? Amazing. The answer is true, since they lie on the same plane. Lastly, does line L lies in plane P? Very good. The answer is false, because line L lies in plane Q. Were you able to press the heart react button? Amazing. I hope you were able to enjoy our discussions and activities for today. To summarize, a mathematical system has 4 parts, namely undefined terms, defined terms, postulates, and theorems. Undefined terms do not have any actual definition and may be represented by different figures from the real world, while the defined terms have a formal definition and can be defined using other geometric terms. Postulates are statements that assume to be true, while theorems are statements that can be proved to be true. Then we have the three undefined terms. First is a point. A point refers to a specific location. It has no length, width, and thickness and can be named using a capital letter. A line is made up of infinitely many points. Remember, the two distinct points determine a line. It has no width and thickness, but it has an infinite length that extends indefinitely in two opposite directions. It can be named using two capital letters or any 2 points on the line, or using a small script letter. And lastly, the plane. A plane is a flat surface made up of infinitely many points that extends in all directions. There is exactly one plane in any 3 points not on the same line. It has no thickness, but it has an infinite length and width. It can be named using a capital script letter placed at one of its corners, or by at least 3 non-collinear points on the plane. Now let us proceed to the question and answer portion. Do you have any questions? Just type your question in the comment section and we will try to answer it. For our first question, kapag po ba sinabing line ay laging straight line dapat, katulad ng mga given sa representations? Pansin ko po kasi laging straight at walang curve na example sa line. That is a great question. And the answer is yes. Sa geometry, ang line ay laging nire-represent gamit ang isang straight na object or illustration. We have here another interesting question. Tungkol po sa na-discuss nyo ng mga defined terms, yun na po ba lahat ang defined terms in geometry? Thank you for that wonderful question. And the answer is no. Madami pang defined terms ang madidiscuss nyo as you go along sa different topics. Ang mga ito ay magagamit nyo sa mga future topics nyo, lalo na sa proving. Thank you for your interesting questions. If I was not able to address some of your questions, you may just refer it to your subject teacher during your follow-up discussions. For your homework, kindly answer page 6 and page 7 of your alternative delivery mode or ADM. Thank you and have a blessed day.